Okay, let's study the problem of the area under the core. So we have no formula to compute the area when the one side of the figure is a core. Suppose the core que corresponde with this parabola. There's a function f of x is equal x squared minus 4x plus 5. Our goal is determine the area under the core. Okay, but the area in between, for example, 1 and 4. Okay, this area. And you see that one side is a curve and the other no, the other is a straight line. Now, the way to determine is using the integration, the defined integral. This is a symbolic way. After we explain detail the symbolic way, I call S. S is the area under the curve between 1 and 4, and the answer is 6. Now, to understand how the integral compute this answer, let's go to the Riemann zone. Riemann zone is the summation of the small rectangle, okay, under the core. Let's using one graphic approximation. Suppose this is slide. You change the amount of rectangles. Suppose 2. Now you see the area under the core. The value is 4.88. It's smaller now. It's obvious, no? The area under the core is the red part, and the other is the blue part. Okay. Now, when you increasing the number of rectangles, and of course the width of each rectangle is smaller, the figure little by little is taking the value approximately the actual value of the area under the curve. You see it's 5.28, and little by little when you increasing the number of rectangle, wow, the area is approximate. I'm using in total 50 rectangles, and look, the answer is almost 6. It's 5.91. So you increase it to infinity, the number of rectangles you obtain exactly the area under the core. So the conclusion of this part is the Riemann zone, when the n approaches to infinity, so the number of rectangles increasing forever, is equal to the area under the core. And this is the central idea for the defined integral. Okay, we're using the Riemann zone to define the integral, the defined integral. As for example, we have let a function f in one specific domain over the real number, and we suppose that the domain is subset of the real number. Let take the interval I, a comma b, close interval in D, and be a partition of I where partition P, let me call P, is equal the set formed by, suppose x0, x1, x1, comma x2 comma comma x n sub m minus 1 comma x sub m. When, for example, a is equal x sub 0, and of course the rest is less than x1, less than x2, less than less than x sub m is equal b. Now, a Riemann sum. A Riemann sum of f over I with partition P is defined as suppose capital S sub m is equal summation from I equal 1 to m of f evaluating x sub I after multiplication by delta x sub I. Who is x sub I after? Is a number below or between any partition, arbitrary. And delta x sub I is a subtraction x sub I, for example, minus x sub I minus 1. Okay, there are four methods of the create the Riemann sum. The first one is using left endpoint. The second is right endpoint. Another is middle point. And finally, is trapezoidal. Okay, let's see. Okay, in this case, we're using the left endpoint to evaluate the function. Okay, in this case, we're using the right to evaluate the function. In this case, you evaluate the midpoint to evaluate the function. Depends if the function is increasing or decreasing. Any method over or underestimate the integral. Okay, thus a more accurate method is using trapezoidal, like that. Trapezoidal method in which you're connecting the both endpoints and you form a trapezoid and compute the area of the trapezoid, not rectangle. It's much better, and you converge the Riemann sum faster, not necessarily increasing a lot of the number of the trapezoid. Okay, definition of defining the integral. Okay, there are many ways to define the integral. However, the most frequently using is using Riemann sum. If f is a function defined on the closed interval a comma b, the defining the integral of f from A to B is a number S, in which the limit on the maximum delta x approaching to 0 of the one Riemann sum, summation for the e equal 1 to m, f evaluate and x after multiplication by delta xi. The most important in the definition is if the limit exists, we can say that f, the function f, is integrable on the interval, the closed interval a comma b. Okay, entonces now the symbolic way to indicate this idea is, okay, integral from a to b of the f of x dx is equal s. That means okay, for all epsilon positive exists a delta positive also, such that the absolute value of x minus s sub m is less than epsilon for all partition P of the closed interval a comma b, with, of course, delta x maximum, so the maximum value of the delta x is less than delta, and it is valid for all possible x sub b after inside the subpartition x I minus 1 comma xi, the interval inside the partition. Okay.